Hello. Today we're going to take a look at geometric sequences. We're going to understand the equation, and then we're going to learn how to derive an equation if you're given 2 points in the sequence. Okay, let's go. Okay, so here is the general form for a geometric sequence. And a sequence is a series of numbers that follow a pattern. So a geometric sequence, a sub n equals a sub 1 times r to the n minus 1. Well, let's take a look at what each of those terms mean. So a sub 1 is the value of the first term of the sequence. A sub n is the value of the nth term. R is the common ratio. That is the multiplier that can be applied to each term to get the next term. And that's what makes this a geometric sequence as opposed to an arithmetic. An arithmetic has a D, a common difference, something that you add or subtract between each term to get the next. A geometric has a common ratio, something that you multiply each term by to get the next. And that should sound familiar. Geometric sequence is the same as an exponential equation, ab to the x, and you'll see some similarities. You've got a first term, you've got a common multiplier, you've got an input, and you've got an output. And finally, n is the number of your term. So n is like your x, and a sub n is like your y. Okay, let's apply all of this to a specific problem. So let's take a look at this problem. Find the 10th term of a geometric sequence whose third term is negative 96 and whose eighth term is negative 98,304. All right, the start to any of these problems is write the formula on the page. So let's do that. And our next step will be to fill in this formula twice. Once for each term we've got. So once we're going to fill it in for the third term being negative 96, and then we're going to do it again for the eighth term being negative 98,304. And if it's helpful, make a little t-table on the side so that you don't forget which number goes where. So there's our t-table. And now we're going to fill these two equations out. I always like to place the equation with the larger n on top. So here's what I do. There are my two equations, and I'm now going to go ahead and solve them simultaneously to eliminate a variable. If you watched my video on arithmetic sequence, and if you haven't, there'll be a link to it at the end of this, then you know that I solved simultaneously with those by subtracting one from the other. Now, in a geometric sequence, our a sub 1 is multiplied to our r. So to get rid of it, we can't subtract, we have to divide. So first, I'm going to clean up the subtraction in the exponent, and then I'm going to divide, and my a sub 1 divided by a sub 1 will become just 1, which will make it essentially disappear. And you recall our rules of exponents tell us that when we are dividing r to the 7th by r to the 2nd, that's the same as r to the 7 minus 2 or r to the 5th. And so our last step is to get r by itself, and we can do that in our calculator by either taking the 5th root of both sides or raising both sides to the 1/5. And I find out that my r, my common ratio, is 4. Now, there are two ways to go forward from here. The first is I notice I only need the 10th term. So I already have the 8th term. I could go ahead and just say, well, my 9th term will be this number times my common ratio. And to get my 10th term, I do it one more time. That's a large number. What monstrous teacher made up this problem? So that's one way to get there, but I'm going to teach you the other way in case either instead of asking for the 10th term, they ask for the 600th term and you don't want to, grind that out manually, or if in addition to asking for the 10th term, they ask for the general equation, in which case we would want to know how to keep solving and get that a sub 1. So here's all you do. You have your r. So now go grab one of your two equations put your 4 in for your r, and solve for your last variable. And in doing my steps, I find that my a sub 1 is -6, and now I can take my parent equation and fill in my 2 variables, and I'm now equipped to plug any n in and find the value of the a sub nth term. So I'll do that for 10 to finish up. And you see, I get the same monstrously large number as I got by just hopping up 2 more terms from where I started. So that's a first glance at geometric sequence, how to understand and apply the formula, and then how to derive the formula if you're given 2 points in the sequence. So play the video again, do it along with me, click on some of these links and check out some other sequence and series videos, and consider subscribing so that whenever I put out a new video, you are alerted so that you can keep on mathing.